All right, welcome. We have, I'm kind of excited, not because you have a test tomorrow. That doesn't, I don't know if that's exciting, but we're going to wrap this little mini lesson up unit today. And then you have a test tomorrow, and I think you could do pretty well. I could do pretty well. I do want to spend a little bit of time today kind of wrapping up leftovers and then maybe reviewing a little bit also. Now, after the test, I would like to introduce you to a project. So what we'll do is we probably only have peer groups on Thursday, probably for half the time. And then the other half the time, I would tell you about this project you're going to be doing. So each of you is going to be essential in that project, but I haven't decided whether or not I put you in groups on Thursday or let you wait until Monday. I haven't decided yet. One idea is that you go home and think about all the great ideas you have, and then it doesn't matter what group you're in because you have all these great ideas you're going to bring. See it? Because if I put you in a group too early, and you know there's one person who's going to think of a lot of things, and you won't do anything. So I'm kind of leaning that way. I'll tell you what the project's about. You have like 3 days to think about it, and then you start on Monday, like that. I want to remind you about this project here, the Eratosthenes project. Don't forget that. That's due on Monday. So you want to give yourself, it's not, I don't know if it's going to be sunny. Maybe it was sunny today. I don't know, but I know that Thursday, Friday, Saturday, Sunday are going to be sunny. So try to find out when solar noon is. Get out there, get your equipment out, take a few measurements. You should be done, really, within 15 minutes to get the measurements. And then you just have to write it up like that. Excuse me. Excuse me. Okay. So what I'm going to do is the first thing that here's something we didn't get to yesterday. I'm going to review a little bit, just a tiny bit here. As far as dates, this has like 2 full pages of dates. I'm not asking for that. I'm not asking for that. It is interesting to have all these different dates in here, but the ones I think are the most important are something like here. I actually do think it's kind of neat that the metric system hadn't even been officially adopted by France, where it came from. It hadn't even been adopted there, and Thomas Jefferson saying, you know, we should have our money system in this new country should be based on something that makes sense, not what everybody else is using, 16 of these and 8 of those and stuff like that. So he actually did do that, and we had the first decimal-based money system. And then the French Academy of Sciences, they have the metric system kind of started here. But there was a war going on, and I understand that. If I was I didn't want to lose a war. The last thing I'd want to do is thinking some of my commanders are using these units, and somebody said, hey, how far away are you? Oh, we're this many, I guess these kilometer things. That would be bad. So he kind of temporarily suspended the idea of using it. He was all in, I believe, but he suspended that. It took almost a little more than 45 years later before France adopted it. So they were the first country. So this is when it kind of started, right before 1800. That's what I like you to remember, right before 1800. That's pretty easy. Next. This is not a real important date, but it's interesting in that the United States acted like, well, this metric thing is catching on, and we need to at least accept it's at least legal to have metric units. But this is the one I thought was important here also. This it's like all the countries in the world, and whether there were 17 or 18 nations here, it doesn't matter. Wow. They said, this is going to happen. This is going to happen. It's going to go worldwide. And that takes a lot of leaders. And so these big countries came and said, are you in? And we said, we're in. The United States was there. And they said, okay, if you're in, then just give us some time. We're going to make you these copies of the master, okay? The master kilogram and the master meter. You're going to get copies of that thing. And so we got our copies here. And then not a whole lot happened there, really. And so the rest of the world was changing a little bit. But again, even England, I think it was 1965 before they completely changed. Canada was 1970. Even they were hesitant. So But I think they were figuring out that, hey, we're not doing all of our trade with the United States anymore. We're doing as much trade with Europe as we are. So maybe they figured out for their economy it'd be better to go metric. And then, let's see, somewhere around 1960, people come back and they said, you know, the metric system is a nice thing, but it's not keeping up with all the stuff we're doing. And so we're going to kind of modernize it. What do they call the modernized version? SI. And instead of having 3 base units, they had how many? 7. But they still like the idea of using powers of 10. They still like the idea of using connectedness, right? So every derived unit, and a derived unit means derived from the base units, right, had to be defined in terms of the base units. So that happened around 1960. And even though this looks like United States is finally going to enter the rest of the world, but it was all voluntary, and you know what? Wasn't going to happen. Wasn't going to happen. And so we really never have forced the people to go to metric system. Now, it is true, every time you go to the store, you buy 2 liters of Coke or something like that, right? And it's very common to use the word liters, right? If you're in any kind of sports, that's all metric, isn't it? Everything's metric there. The military is metric. Hospitals are metric. See that? Oh, well, actually, babies, they still talk about how many pounds, don't they? Yeah, they still do pounds. Well, anyway, and then in 1994, well, at least every product that's made has to have dual labeling in it. And again, I think they could actually make more money by selling it in other countries. They wouldn't be able to sell in another country if they didn't have the metric labels on it. That's a real quick history thing there. And then yesterday, we looked at this, and again, I would never have you memorize this chart. I would give you this chart. Everybody get it? You'll get the chart. You just have to know how to use it. So what do you think? If you saw that on a test tomorrow and I said, which SI base units were used to define let's pick one. How about the Coulomb? That would be a hard one. So you have to find it. Oh, Coulomb measures electrical charge. A Coulomb is defined as a what? And this is, you say, what is that? That's an amp second. An amp second. Or either one of those base units. Both of them are. That's 2. But what in the world is... Oh, I'm done there. No, we're done with that. I should have picked a harder one. Anyway, we did ohm yesterday, didn't we? And so we found ampere, but then we had to go down to volt. We had to keep going up like that. What do you think about that? Pretty good? All right. The last thing that we did, I think I handed you this sheet here. Is that correct? All right. I know. We also did this. One of my goals is that if you, I don't want you to act like, well, I don't really have to learn the metric system. I think you'll be shocked as you get older. Maybe 20 years ago, I could have told people, well, maybe you'll be all right. But I think you live in a world now where you really do have to know both systems. Now I can't find it. Here it is. So when you go to this page here, I wanted these to be common. I wanted you to say, could you relate this to something? If somebody said, I have 3 liters, could you estimate what 3 liters would be? Would that be hard for you? What if I told you about a gallon and you say, how many liters do you think are in a gallon? Is that something you could estimate? You say, well, I know that a liter is just a little bit bigger than a quart. Is that right? I know there's 4 quarts in a gallon, so it must be just a little bit less than 4 liters in a gallon. And you'd be right. It's pretty close to 4, isn't it? All right. So I want you to be able to estimate things in the metric system. So we're going to go here, and we're going to go down the row, and let's see, walk around. Let's start this way and go this way like that. And let's go to number 1 and see it. And if you honestly say, you know, I really don't know how to estimate that, I'll try to give you an example. I'll try to help you out. Do number 1, read it, and what do you think it is? We got to read it. What now?
Oh, you mean read the
Yeah.
a regular size paper clip.
Okay, I'm gonna read the question.
Oh, okay.
Okay.
A gram is about the mass of a regular size paper.
What do you think about that?
True.
That's true. Okay, I like that one. Okay, let's go to the next one. Jessica.
Metry is about the same as,
Go, wait, they can't hear you.
a metry is about the same as the height of a doorknob.
Okay, and so you know that one. And meter, even though they spelled R-E, we still say meter, just like theater, or, you know. All right, next.
Water boils and freezes at 100 degrees Celsius and 0 degrees.
Okay, so, all right, so you feel comfortable with this? All right, next, Sarah.
A newborn baby has a mass weight of about.
And can I tell you something? This is kind of funny. The guys have no idea. And the guys, if you told them to do it in pounds, it'd be just a joke. A lot of the girls here, I'm not to be sexist, but a lot of the girls in here, you know about what it's going to be in pounds. The guys have no idea probably. If they told you the baby was probably 20 pounds, the girls say, they'd laugh because they know it. That's, you know. What do you think, Sarah? I'm not putting any pressure on here, but what do you think about in metrics?
C.
Which one?
C.
All right, B, C.
C.
All right. Anyway, a kilogram is about 2.2 pounds, and 3 kilograms would be about 6.6 pounds, and that's a good one. Good one. Anybody thought it was 30 milligrams? If a gram's a paperclip, a milligram's a thousandth of a paperclip. No, okay. All right, next. We're going to go a little faster now. Go. Read the prefix kilo.
Oh, is it my turn?
Yeah.
Kilo is 1,000 times a, or, yeah, 1,000 times a kilo.
Okay, yeah. All right, next.
The college basketball player is about 200 centimeters.
Okay, let's think about that. What would 200 millimeters look like?
That's kind of small.
Well, what's 200 millimeters look like, though? What's a millimeter?
Well, that's centimeters.
Okay, so this is 10 centimeters, isn't it? That's 100 millimeters. So what would 200 millimeters look like?
Double that.
2 of those, okay. Next one. How about 200 centimeters? How big is that? Is that 2 meters 6? Isn't a meter 6 100 centimeters? So you think it's about 2 meters 6 tall? I think that sounds pretty good to me. What about 200 kilometers? All right, hopefully you wouldn't have put that. 2,000 decimeters. What's a decimeter? All right, you're not fooling me. I know that's a decimeter, right? Okay, so we got that one. Next.
Normal body temperature is about 37 degrees.
All right, the whole world knows that. Now you know it. All right, next.
A regular size soft drink can is about 0.5 liters.
All right, which one?
A.
Okay, let's think about that. This is a liter. Is that right? What do you think about the soft drink can? A little smaller than that, maybe? All right, so smaller than that. So which one are you going to throw away?
A and B.
And if it's mainly water, 100 grams of water would be about 100 milliliters. I mean, 1,000 milliliters. So what do you think about answer D? Is the can about that big? Not really. So I'm getting rid of that one. What is 60 cc's? What's a cubic centimeter look like?
It's like a centimeter.
Well, isn't that 1 milliliter?
A cubic centimeter is a milliliter, isn't it? Okay, so 60 milliliters. This is how many milliliters? 1,000?
It's not a lot.
No, 60's not. No, that's out. How about 1.5 liters?
Yes.
There's 1 liter. 1.5 liters? No. Actually, I think you said it right. Didn't you say A? Very good. All right, let's go down to number 9. And read the question, too.
A liter of water has a mass weight of about
They did this on purpose. What?
1,000 grams.
Yes, it's a kilogram, isn't it? Number 10.
A new piece of chalk has a length of about 8 centimeters.
You can see how long I've been using this paper for like 20 years. Do you know a piece of chalk's about this big? Now, does that help you? When you get a brand new piece of chalk, it's about this big. But you haven't seen chalk in your whole lifetime, have you? Except sidewalk chalk. All right. All right, number 10, what did you say it was, Jeff?
I said it was 8 centimeters.
Show me 8 millimeters.
8 millimeters?
Show me 8 millimeters. This way?
How much, maybe?
8 millimeters. That's isn't that? That's less than a centimeter, isn't it? Okay. How about
It's exact.
8 centimeters?
It's, I don't know.
That's 10 centimeters, right?
Bigger.
10, 8 centimeters,
Yeah.
8 decimeters.
We're up to my hand right now.
Well, that's 10,000 bigger than that.
All right. So which one do you think it is?
Centimeters.
8 centimeters. Good. All right. Next. Ooh, dollar bill.
$8 bill is about, I'm gonna go with 7 centimeters by 15.
Which one?
7 centimeters by 15 centimeters.
Okay. So we'll put a question mark there. What about 70? Show me 70 centimeters. Wait. A meter six, 100. A meter six, 100. So, all right, 70. All right, so that's out. It's not that big. How about show me a decimeter? Oh, that might be in. Show me 3 centimeters. That's out. That makes air out. Okay, what about 20 millimeters? Very good. All right, and you're correct. That is correct. Very good. That's what I want you to be able to do. You see that? If you can just say, I know some common things. I know this. I know the 100. See that? I just want you to be able to relax a little bit and say, it's not so bad. All right, next one.
Oh, I said D, millimeters.
Which one? Yeah, and they had a picture of that. It is a millimeter. Next.
Base unit of length in the metric system is the meter.
Right. Next. Yes. Alistair.
The commonly used unit of scale in the metric system is the Celsius scale.
And even though Celsius is used in metric, any kind of mathematics, equations and things used in physics or chemistry, they always convert to Kelvin, don't they? But humans still like the Celsius scale because of the numbers they get. Next. Back up here, Walker.
The correct symbol for grams is G.
Right. Next.
The correct symbol for 100 cubic centimeters is D.
And even though this is the answer is D, in the medical community, they would actually use 100 cc's. That would be the same for them. So in the medical community, I'd say that they would probably say C. But in the scientific community, they'd probably do that.
So, are there 2 right answers?
So I think there'd be 2 answers there. I wouldn't, if I put that on the test, I'd have to take 2 answers on that. Okay, good question. All right, let's go on. Anybody feeling a little bit better about metrics? A little bit? All right. 17.
A unit used to measure mass in the metric system, kilogram.
Okay. And 18?
The unit of measure for measuring carpet in the metric system. Square meter.
Right. I have some questions on the test. I'll say, what is the most appropriate unit for measuring, and I might say, a carpeting for this room? Now, you could say square centimeters, but that would not be the most appropriate because it would be such a tiny thing, wouldn't it? There'd be a couple million, a couple 100,000 of them. So that would not be, square meters would be the most appropriate. What if I said, find the volume of this right here? The volume of that. What's the most appropriate unit for the volume of that? I need somebody take a stab at it. I'll tell you if you got it right or wrong. What is it? What would be the most appropriate metric unit for measuring the volume of that?
That's millimeters. Centimeters.
Did you understand the carpeting question? Okay, the same thing, except this is not area. This is volume. Cubic centimeters. A cubic meter would be too big. That would not be appropriate. Cubic millimeter, that's too small. Cubic centimeter, yeah, I would say that. Next. I think Parker's. Wait,
Yeah. Would be C, 50.
what do you think? 50? What do you think? So, and that's okay. Wait, I'm okay. What do you know about Celsius? Let's see, ice is 0, boiling water 100. How about my body temperature? Body temperature is 37. That's 98.6. So, all right. So, what do you think? And that's all I want you to do. I want you to say, I've got some little markers that I can estimate with. Next, 10.
The approximate mass of 1 cubic centimeter of water is 1 kilogram.
How much?
D.
Say it again.
D.
I can't hear.
D.
E. Oh. Wait, this one? This one? This one? They did it on purpose. 1 milliliter of water, which is 1 cubic centimeter water, has a mass of 1 gram. They did it on purpose, okay? Next.
1 decimeter is about the same as
Hey, Sarah, can you close that door for me, please?
the width of your hand.
Right, and a decimeter is about like this, right? So some people's hands, mine may be a little big, but some people probably have a decimeter maybe here. Some of you have a decimeter here, okay? You gonna like that one? 12.
To measure long distances, you would use the barometer.
Yes, All right, 23.
The metric system is based upon the powers of 10.
And the person who wrote that is definitely not multiples. Multiples of 10 are 10, 20, 30, 40. It's actually powers of 10. 14.
Oh, the symbol for the modernized version of the metric system is SI.
Right, okay. 25. And Jeff, I'll give you put you on a little pressure. What does SI stand for?
Maybe like
Maybe?
standard something.
What is it?
Something like standard something.
That's not a bad guess. Not a bad guess. What do you think?
System Internacional.
Okay, and we call it the international system, but the System International, okay? Next, 25.
The basic unit for capacity in the metric system is I'm gonna go with liter.
Capacity is volume, and even though liters is in the metric system, the SI, there is no liter in SI because the volume can be measured as cubic decimeters, can it? It can be defined in terms of the meter stick. That's why you don't see the word liter in the SI chart. Next, 26.
I said C.
Which one?
C.
B? C? Okay, you're right. And a millimeter is almost always the smallest mark on a meter stick or even a metric ruler. 27.
Cubic centimeter is a unit of length.
Now, even though I have several questions on the test that ask you about this, right? A distance unit like this is distance. And that could be length and width and radius and circumference, that kind of stuff, right? But what if you see this? That's not length anymore. What is that? It's area. When you see a distance unit to the second power, it's area. If you see a distance unit to the third power, it's the third dimension. That's called volume, isn't it? A cubic foot is volume. A cubic mile, all right, that's volume. So anyway, you have to get that out of your head that even though it looks like a distance unit, it's not distance. So this one is a cubic centimeter would be volume. 28.
The thickness of the sheet of postboard will be measured in millimeters.
And it depends. If it's like foam board, I would say, millimeters. I can't think of any other one that would fit. Micrometers are really, really small. It takes 1,000 micrometers, as they're called microns, to get it to be a millimeter. So I don't think that's it. 29, last one. Wow, Walker, you could do another one.
The most commonly used measurement system in the world is the SI metric system.
Okay, that was pretty easy, right? Do you at least feel a little bit more comfortable that you have some little markers that go by? Remember how a kilometer is a little more than half a mile? So it's not like if you go to Italy, it's not like, I'll show you a little trick with that one too. If you do go to Italy, a little trick. If a kilometer is like 0.6 of a mile, the fraction 3/5 is 0.6. See that? You could use the fraction 3/5 or 5/3 depending on which way you want to go. There are always going to be more kilometers than there are miles because kilometers are smaller. So if somebody said you're going to go 100, let's say you're going to go 60 miles. If you're going to go 60 miles, how many kilometers would that be? You say, well, am I going to use 3/5 or 5/3? If I go 60 miles, I'm going more than 60 kilometers, aren't I? So I have to use 5/3. 5/3 times 60. We'll do a little math here. Ready? 60 times 5/3 in your head. You can do it. Cancel. 20. 20 times 5. 100. I tend to use 100 kilometers per hour, or 100 kilometers is the same as 60 miles. In my car, if I go 60 miles per hour, that's like 100 kilometers per hour. And again, that 3/5, 5/3 fraction comes into play, like that. All right, questions on that? All right, leftovers, and then we look at the practice test. I think I mentioned these words. I'm going to do them again. Anytime you have a unit on measurement, these two words come up. They're Q words. One's qualitative, one's quantitative. Everybody got that? Everybody got the difference? In this lab, most of the time in physics, almost everything you do deals with measurement. That means you're going to do a quantitative lab. You have quantitative results. Got that? Okay. We talked about measurements have what three things in common. We also talked about accuracy versus precision. I don't think I mentioned this. This is a minor thing, but when you guys start doing your project, you'll have to understand there's all other things that people always know about measurement. Now, for example, I'm going to get a ruler out here. And if I were going to measure something, what I'd want to do is I have to know a little bit more about measurement. Now, for example, here I have this thing here, and I'm going to measure it. So what I might want to do is I might want to put it on the end of the ruler, but is the end of the ruler 0? So whether I use a $2 ruler or whether I've actually done work with a $60,000 piece of equipment. Guess what I had to do before I used that equipment? I had to zero it. When I use electronic balance in here, the first thing I do, zero it. I have to tell it where 0 is. How do you zero a ruler? How do I zero a ruler? Well, you have to look to see if the end of the ruler is 0. See that? Can you guys see that very well? So is the end of the ruler actually 0? And, oh, hey there. Thank you. She's practicing volleyball, so it's okay. No, she wasn't. I was just kidding. Volleyball players get a pass. You know, that's the way it is.
They're like the jocks.
It's one of those lost books of the Bible or something. No, just kidding. All right. Anyway, so if I want to zero this instrument, I got to make sure I'm on 0, right? I know it sounds obvious to you, but can I give you another clue? What if the end of the ruler is kind of beat up? If the end of the ruler is kind of beat up, or what if I'm not sure if the end of the ruler is 0? There's another way of zeroing. Watch. I'm going to start at 10. I'm going to start at 10, and if I go to about 18.55, I just have to subtract 10, don't I? That's another way that I can zero my instrument. So if I don't feel comfortable using the end, because a lot of the meter sticks we have here, the end's kind of beat up a little bit. I never measure from the end of a wooden meter stick because I can't tell exactly where 0 is. Another thing we have to worry about, not so much with these flat rulers, but you get a ruler that has some thickness to it, and we have to worry about this thing called parallax. Now, parallax is in the terms of measurement, that's a bad thing. So I'm going to show you a little demonstration of parallax. And what I'm going to do is just do what I tell you to do, okay? Do what I tell you to do. And can everybody see that X there? Now, what I'm going to ask you to do is to, you're going to put your hand out like this, and you're going to make like a circle. Now, not yet, but when I say go, I want your arms to go straight up. Both eyes are open. Watch now. Both eyes are open. And my arms have to be straight. Not yet. And I want the X to be inside that circle. So don't do it yet. One more time. Arms are straight. You got a little circle. And both eyes are open. And when you put that X in there, do not, I don't want to see anybody's hand going back and left and right. You get that? 1, 2, 3, go. Don't move anything. Now, ready? Stay right there. Close your left eye. If you still see the X, then you're right eye dominant. Now close your right eye. If you still see it, you're left eye dominant. That's another thing. A lot of people don't know that your brain is wired. How many people in here, you know you're right eye dominant? All right, how many of you are left eye dominant? Now, even though it doesn't come into play very often, I think you said something about shooting. There are people who are very, very serious about target shooting. And are you right eye dominant?
I'm right eye dominant. My mom shoots cross-handed.
Okay.
She's right hand dominant, but left eye. So she has
She's right hand dominant, but her left eye is actually taking most of the information that's coming from that eye. So what they're doing is you just got to put your right eye there, right? And she goes across here. Is that what she does? Or does she just...
She doesn't really shoot. She typically shoots pistol, but she has to
So
move it off
every
to the right.
all of you need to know that you're wired a little bit differently. One of your eye actually sends a more dominant signal than the other. Now, it doesn't make that much difference in your life. You know, not really, a little bit. And what I was going to show you, that tells you about which eye is dominant. Now, I have another demonstration. Now, this time you're going to put one hand out like this. Now, wait, no, not yet. You're going to close one eye. You're going to put one finger out and cover up the X. Okay, so cover up the X.
Oh, what?
Now, wait, now, is that X covered up? All right, now, don't move your hand. Switch eyes. Switch eyes. Do it again, and again, and again, and again. Now, what you should have noticed is it looks as if your finger moved left and right, doesn't it? And that's what parallax is. Parallax is the apparent shifting of an observer, but you're not really shifting, but it just has to do with God gave you two eyes. And the fact you have two eyes, you have to be careful because which one is your brain paying attention to? If I measure this way, then if I measure with my right eye dominant, then I must be seeing it like this way or this way. Which way am I seeing it? And so this kind of a ruler, it doesn't make as much difference because it's really flat, but imagine a ruler that came off the table a little bit. You'd be trying to measure carefully, and you got both eyes open. If you have both eyes open, you're taking a chance that you're getting what they call parallax error. One eye seeing this, and one eye seeing something slightly different than that. And so when you measure, you'd probably want to use just one eye. And you won't have to worry about that. They have the same thing that happens. Oops, I thought I had a battery cell back here. The company who makes this, they understand some of these concepts of measurement. So let me show you this on the board again. So we have this graduated cylinder, and you notice that they have a line. See the line for 70 and then 71. We talked about that the other day. And notice, though, that, okay, it costs them a certain amount of money to put this line here and that line there. But then every 10, they made the line go all the way around. And the question is, why? Why did you need that line to go all the way around? Is that necessary? It's just extra cost. But they actually know about parallax. So here's what happens. When you're measuring a graduated cylinder, you're supposed to read the bottom of the meniscus. The meniscus is that little bowl-shaped thing. Water is attracted to the glass, so the rim gets pulled up, and the bottom sags. See that? So everybody who makes these knows that you're supposed to read the lowest part of the meniscus. Now, if your eye is up here, then you are looking at the glass here to see the bottom of the meniscus. But if your eye is here, then you're looking at this part of the glass to see the bottom of the meniscus, and that's called parallax error. So where's your eye supposed to be? Your eye is supposed to be absolutely perpendicular. So how they do that? They give you, about every 10 milliliters, they give you a line like this. So if I'm using this graduated cylinder correctly, then I would say, oh wait, I see two lines for 70. If I see, watch this now. If I see two lines for 70, I must not be perpendicular to the surface. But if the front paint line covers up the back paint line, then I know my eye is perpendicular. So even a company who makes this understands that thing called parallax error. Now I think that's about everything I have for you. Now, what I like to do is, I think I had given everybody one of these. Does everybody have that? So what we'll do is, the rest of the period, we'll do the same thing. We'll go around the room. I don't care. You shouldn't care. I don't want, don't worry about making a mistake. We're not worried about making a mistake. We want to talk about it. Now, a student made this. A student made this about 4 or 5 years ago. He really enjoyed making practice tests. He was actually good with it. He actually sent these practice tests to other people in the class, and they appreciated him doing it. And then I started handing them out then. All right. So anyway, let's pretend this is like a test. And where did we leave off last time? I think Walker, Jessica, I think you did. All right. Read the first one, and let's see what happened.
Which measure was first defined as the distance from the tip of the nose to the tongue of the extended hand of the English King Henry I? B, or no, C, sorry.
Which one?
Meter.
Okay. What do you think about that? If you remember the French Academy of Sciences, that's one thing they were not going to get into. They were not going to use their country's king or anything that was French, right? So the metric system was not based on anybody's body part. So let's try another one. So it wasn't the meter.
Oh gosh.
You think you know?
Feet.
Which one?
Yard.
Yard, right. And if you think about a yard, it's more than a foot, isn't it? It's going to be more than a foot. Next, number 2.
What country is responsible for the
Conception.
conception of the SI system? Isn't it France?
Yeah. Next.
Which U.S. president received on behalf of the United States the national prototype of the meter and of the kilogram from France? Harrison.
Okay. And that was in the article we read. 4.
Which of the following is not characteristic of a long-lasting standard unit of measure?
Ah. Remember there were 3 things. They were... What do you think about A? Do you think a standard should be widely available, readily available? Yes?
I guess it
What's that mean?
should not be invariable.
What's that mean?
That it can be different.
Right, we don't want a ruler over there to be different than a ruler here. What about the next one?
The standard shouldn't be accepted by everybody.
That's interesting because I'm reading this, and I didn't write this question, but it should be easy to use. Huh. What did he say the answer was? What did he think? I'd have trouble with this one. He said C. Honestly, a standard, I'm sure people in England didn't want to change, but the government made them change. See that? But then guess what? It wouldn't have worked unless the people said what? The government's asked me to do this. What? I accept that. If they decided they weren't going to accept it, they wouldn't have changed, would they? So I don't know about that one. I wouldn't write it like this. I think there'd be all of them. I think all of them there. But in the article, they talked about these 3. The article didn't talk about that, but it's not going to work if everybody doesn't accept it. Number 5.
The standard metric unit of length is the meter.
Oh man, this is too easy. Okay, 6.
A kilometer is less than a mile. False.
Okay, let's think about that. If you know what a mile is, how does a kilometer compare to it?
It's like 1 point something.
It's only about a little over half a mile. So a kilometer is definitely smaller than a mile. It's only about 6/10 of a mile, okay? So it says here a kilometer is less than a mile. That's true. That's why, I think what I get confused is, that's why there's more kilometers than there are miles. See, 60 miles is how many kilometers? 100, that's confusing because there are more kilometers because they're smaller. The same distance, I need more kilometers to equal that distance. All right, next, 7.
1 cubic decimeter is equal to approximately 1,000 cubic centimeters.
This is a cubic decimeter, and you are correct. Ding, ding, ding. It is 1,000. Where am I at? It is 1,000 cubic centimeters. You're right. Next. Uh-oh.
8.
The thickness of the dime is closest to what you would call
Mm.
I believe it is d to the 1 to the negative 10, 1 times 10 to the negative 2nd centimeters.
Wait, which one?
C.
C? All right, let's think about that. A centimeter is this big. This is 1/100th of a centimeter. Is it 100th of a centimeter? It would be 1/10 of a centimeter. If they said 10 to the minus 1 centimeters, that'd be okay. And we know it's a millimeter, don't we? 1 times 10, that's 10 millimeters. You're out. You're out. 1 times 10, oh, they've been tricky, isn't they? 10 to the 0 is 1, isn't it? What's 1 times 1? Okay, that's him. That's a tricky way of saying 1 millimeter. Next.
The height of a doorknob is about 1 meter.
Yeah. Next.
You got easy ones. Yeah.
The width of the fingernail is about 1 centimeter.
Right. That's a question I wrote on there on his paper. How many SI base units used to define the Newton, the Joule, the Ohm? We did that yesterday. Okay, so let's move on. Now I have some questions like this on the test, so I'm glad you put these on there. Yes.
The Newton, the Joule, and the Ohm one, is that gonna be on the test?
Oh yeah, but I will give you the chart.
Okay, okay.
Yeah, I definitely will give you the chart. You just have to know how to use it. All right, ready? 11, quickly. Length, 12. Yes, 13.
Temperature.
Yes, 14.
Mass.
Yes, 15. Back up to Walker.
Volume.
Yes, 16. Cubic centimeters volume, yes. Yes, 17.
Temperature.
Yes, 18. Yes, area, 19. Parker, 19.
19 is mass. Or, I mean, not mass, sorry, volume.
It is volume. If a liter is volume, then a kiloliter is volume, isn't it? Next.
Volume.
Yes, you're good. All right. Now remember the sig fig rules, okay? There's only 3 that you really have to pay attention to, and the third one is, remember that? Trailing zeros means they trail a sig fig, and then if there's a decimal, it counts. All right, where would we leave off? Are you ready? Let's go fast. Let's see if we can go fast. Ready? How many significant figures in this one?
5.
Yes. Yes. You're undefeated. You every question right. Next.
Oh.
How many?
Oh.
I can't hear. Okay.
Put
Next.
your math inside your math next
Wait,
time.
what? Next.
23.
3. Yes. Next.
4.
Yes.
4.
How many?
4.
How many?
4.
I can hear this one, but that means give me a different answer. See, remember, there's no rule that would make these significant. None of those zeros are significant, right? There's no rule for them. You go left to right. I don't even start counting until they get to that guy. And then there's a trailing 0, and there's a decimal, so 3. Next. 27. 5. Yeah, trailing zeros, and there's a decimal. Yes, next.
28.
Yeah.
I thought you meant that was 28.
Would it just be 1?
What?
Would it just be 1?
Yes. You're correct. Next. Yes. Again, if a scientist wanted to tell me that that's not a very good instrument, is it? They had an instrument, it went like this. They had, it says 0, and here's 100,000. And that's what the ruler looked like, and they said, 700,000? See, it tells me that wasn't a very good instrument, was it?
Exactly.
And if they wanted to tell me it was a better instrument, they could write in scientific notation. This one, if it's only 1, they'd say 7 times 10 to the 5th, right? Okay, next. How many? Yeah, number 30. Walker.
6.
Yes, next. Yes, these are trailing. They trail the 1, and there's a decimal. Yes. You know those Oreo cookie zeros count, don't they?
6.
All right, thank you. Everybody
I was trying
remembers.
to count it, so it's
Okay, all right.
I can't count, so that's why it's hard to
Okay, I'm trying to do these as fast as we can. What I would do, just like we did in class on these, I would put the answer I got on a calculator over here. And then I try to look at the rules. When you deal with measured numbers, you have to round. So if you multiply or divide, what is it rule? You have to round the answer to the least number of sig figs. So if I'm looking at, and this, for some reason, are these all plus?
Yeah.
Okay, I don't know why he would have done that. If you're trying to do a practice test, why we do them all plus? Maybe because he missed the plus on the test.
You should bring him back from college.
Did he miss the?
No, he'll be all right. He's in the world of finance right now. He's doing computer stuff for a pretty big banking company. So he's all right. He made it. All right.
I made big time moves.
Yeah. So the rule, though, when you add or subtract, the rule is the least number of decimal places. You don't even count sig figs when you're doing adding and subtracting. Okay, let's do 1. And if you'll tell me what, do you already have this one on the calculator? Who? You have it? You have, all right, yeah.
169.023.
Is that what the calculator said? 169.023?
0237.
Okay. And what are you gonna round to?
169.0.
Okay, so here's thousands place. This is tens place, and this is 10,000s place. So now, if you round to tens place, do you ever look at hundreds place? You have to. Not big enough. So you'd write 169.0, and what kind of unit? Oh, you didn't put units on here. All right, that's all right. That's a practice test. Let's just make one up. All right, where did we leave off? Parker, you do number 36.
36. How many Fahrenheit is? So.
You gonna read it?
Oh, well, you want me to read it?
Yeah,
Well,
we've been doing that all day.
How many degrees separate the freezing and boiling points of water?
Yep. That was actually kind of a big part of the lesson. I was trying to try to tell you. Remember the Fahrenheit Step Company? They built the steps to my Acme water boiling company, and
Oh, wait, was that with the triangle?
yeah,
Is it 180?
yeah. Thanks, sir. Okay, now. Anyway, it was 180, and how many steps are there in the Celsius? There was 100, and if we think of worlds of ratios, that's where we get the 5/9 and the 9/5. All right. What are these two temperatures in Fahrenheit? That would be 32 and 212. All right, next. Okay, everybody, shh, hold up. Tucker, your turn, right?
Yeah. Freeze at 100.
Yep. Two temperatures.
Yep. 0 and 100.
That's right. Next.
Temperature, it's negative 273.
Yeah. Okay. And next. Say it again. 41. And if you remember, the Kelvin scale is the Celsius scale with no negatives. So do you know the answer in Celsius?
For freezing,
Freezing and boiling.
is 0 and
So it's 100 in the Celsius scale. So how many separate in the Kelvin?
100.
That's right. All right. What are these two temperatures? Same.
Oh,
Ice cube and Kelvin.
they're 0 and 100.
Remember that Celsius plus 273 gives you Kelvin.
So 273.
Ice cube is 273. Boiling water.
373.
That's it. Next.
0
Yes.
or 0.0001.
I know. Okay. What's the lowest possible temperature called?
Absolute 0.
Okay. Absolute 0. What's the boiling point of Fahrenheit? Okay. 212. Let's move on. Now, again, this is a practice test. I didn't make it, but at least it's something to jog your memory a little bit. I think even though he had quite a few factor label problems, I think what you're probably looking at, you might want to try this one, 49, and you might want to try 46, something like that. Now, he gave some, what I'm going to do, just like I did before, I will only let you use the equivalents that I give you, except any powers of 10 you're supposed to know, you can do that. So if you look here, how many quarts are present in a 2-liter bottle? What is the given? Please don't say quarts. 2 liters. That's your given, right? Now, here's where you have to have a little strategy. This is metric, and this is English, isn't it? So you got to have something that's going to get you out of the metric system and into the English system. So what do you think you're going to use? Oh, he gave that to you? Well, that may, I wouldn't give that to you. Okay, wait. So he gave you that one. That makes it pretty easy, doesn't it? Okay, all right. You can use it for right now. I won't be that easy. But in this case, he actually, he gave you liters and quarts. Oh, wait a minute. Yeah, he gave you liters and quarts. Okay, that's pretty easy. Okay, so let's go up here. 65 miles per hour. Make sure you put miles here and hours here, okay? And then, now this person, he's doing something a little different here. I will not do this. Here's what he's doing. Okay, he's doing not factor label. He's doing a mathematical equation. Remember the mathematical equation? What is distance times time? Speed. And I won't give this to you because we haven't done that right now. But he's going to say how far can it go? Distance equals speed divided by time. So I'm going to say that's not a good example. All right, I'm done for today.